All right. Next type of question is going to be to do with time of flight. So the time of flight of a projectile is only related to the vertical bit. Remember, or if you think about it, the horizontal bit, all that's doing is making it go across. The staying off the ground thing is up. So it's only really going to be that guy there that has any influence on it. So if that's big, then time of flight will be big. If that's small, time of flight will be small. So if you launch two projectiles with the same launch speed, one's like that, one's like that, obviously this guy here is going to have the longer time of flight because it's steeper, it's got a higher vertical component initially. Alright, so now what we can do is sort of look at ways to manipulate formulas that you've seen before and hopefully that you'll get used to seeing again to find out what the time of flight might be. So what we need to do is find something that's got some sort of speed in it or initial velocity in it. We need to know, have an equation that's got gravity in it. We know that gravity in this case is 9.8 meters per second squared, and it's got to have some sort of t in it. Alright, so the only one that you'll really find that's got all the parameters that we need, v final equals v initial plus at. And in this case here, once again, we're dealing with a vertical acceleration, so it's a vertical initial velocity and it's a vertical final velocity. So we need to go back to the remainder of my projectile flight up here to work out what values we're going to put in. So this is going to be calculated. So you'll be able to calculate the initial bit using your v sine theta from right at the very start. Acceleration due to gravity is always going to be the same, and this one's going to be down, so you can put a minus out the front of it. T is the bit that you're going to have to find out. So we need to go back over here, rearrange that thing to get t on its own, and remember, hopefully maths from year 9, if not year 10, if not year 11, and if not that, then from now, we're going to do inverse operations. The initial velocity's been added to the acceleration and time, so we're going to move to the other side. If we move the thing that's been added, we have to make it a minus, effectively. Then we're going to divide both sides by the a to get rid of that. So v final equals v initial plus at becomes v final take v initial equals at, and then we're going to divide both sides to get that going on its own. T equals v final take v initial divided by the acceleration due to gravity. Alright, so now we've got time of flight. And now you get to make a choice. So this is not going to be a hard choice, but you get to make a choice. Whereabouts is our projectile going to be? Alright, so we can pick the initial point over here, which is going to be this guy here. It's going to be the one you calculated, and then you can pick one of two places. We can pick up the top. We know it's always going to be 0, or I should have done all that crap in the way. We can pick this point here, which is going to be the final, which is going to be the opposite of the initial that you calculated. So 1 t is v final take v initial over a, where v final equals 0. So t is 0 take v initial over minus 9.8. Now you've got to remember where that's going to get you to. So if I set the final vertical velocity to 0, that's only there. It's only halfway through my flight. So in order to get the proper time of flight, whoops, I need to double it. That'll get me the whole flight. Okay. Number 2, what I can do is put in my calculated value of the v initial, and then my negative calculated value, which is what v final is going to be. Remember, if you launch it up at plus 10, it's going to come down at minus 10. Alright, so t is minus v final, because it's going downwards, take v initial divided by minus 9.8. Alright, and that's going to be the time it takes to get all the way back to here, the whole time of flight. Alright, you've got two options. Some people I know in the past have gone for this guy here because you don't have to do anything at the end. Other people just like the simplicity of being able to calculate the initial, knowing what gravity is, and setting the other thing to 0, then multiplying by 2. Multiplying stuff by 2 is not that challenging. And you'll end up in the exact same place. This one here might be a little bit shorter in terms of steps, but they're, it's one big one here, might take an extra step or two, but they're really not that difficult to manage. Either way, you'll end up in the same place. Pick the one that you are most comfortable with and the one that you kind of understand the most.